So in this case, the condition that we are going to look into will be a certain function referred or compared to a constant. We had before f of x when it is being compared to 0. What you're working with, it was the x-axis. Why? Because in the x-axis, y is equal to 0. So you're making comparison with the x-axis to say that is it above the x-axis or is it below the x-axis? So in our case, guys, we are simply saying the function that we are given, we need a condition where the y values will be greater than k, which is the constant, the given constant. So we are comparing the y values to say where y is greater than. Let's just take a consideration of something like this. All right, I'm just gonna have a simple sketch. This is just a basic understanding that you need. All right, let's just say we've got, all right, we can even consider something like this, and this is 1. Let's say there's a point here. Let's say this is 2. Maybe it is corresponding to 14 or 36, whatever that you're given. Let's just put something here like 8 so that it can make sense. 2 versus 8, all right? What we are given here is a graph of f, all right? Whatever that you're given there. So the y values from the x-axis, their y is equal to 0. Then we have got here, for the y-intercept, we have got 1. It is a line where y is equal to 1 throughout. Then we have got the point 28. Y there is what? Is 8. So throughout that line, y is equal to what? To 8. So whatever that you be given from f can be compared to any y value. Let's say y is equal to 8, y is equal to 1. So this is what I want you to understand. When you say f of x, let's say it is greater than 1, you are simply saying that the y values are supposed to be greater than 1. The y values must be greater than 1. So let's consider on our graph. This is y is equal to 1. All right, let's take that one as our consideration. Let me, it's only that I have indicated, or let me just do this quickly. Since you have seen those lines, let me remove this one for y is equal to 8 and work with y is equal to 1. So like I said, f of x is what? Greater than 1. We need a condition where y is greater than 1. This is where y is equal to 1. This is our line, y is equal to 1. So the comparison will be made from that line of y is equal to 1. You compare the values now from that line of what? Y is equal to 1 to say that is this graph that I'm having, its y values, are they greater than 1? Which side are they greater than 1? So if y is equal to 1 is here, it means above, that's on top of the line. These values, they are greater than 1 because y will be going up. This is 1, 2, 3, 4, 5, and so on and so on. Below that line, it means these values, they are less than 1. 0, minus 1, minus 2. These values, they are what? They are less than 1. So your comparison is made from the constant. So meaning to say the constant in our case is going to represent the critical values. The critical values will be taken from that constant. Will be taken, that is the x value at y is equal to what? Y is equal to k. All right, y is equal to k. X values that we'll be having there. So you can make a comparison to say where y is equal to k. So if we say x values, guys, it's going to be like their main. Let's say just x value at y is equal to k. That will be your critical value. So in our case, y is equal to 1. So the critical value, where y is equal to 1, the x value is what? Is corresponding to the graph where it was going to meet with the graph here and the y-axis. Just pardon the way that I've drawn my graph, but it was going to be exactly in the y-axis where x is equal to what? Where x is equal to 0. So meaning to say our comparison from that value of x, which is our critical value, the x value, x is equal to what? To 0. So we are comparing to say, for this condition where x is equal to 0, to the right side, what is happening with our graph? Our graph is above. It is going up. It is what? Positive. It is more positive. That it is greater than 1. All right. From this, x is equal to 0. If we consider to the left side, our graph is below y is equal to 1. Meaning to say our graph is less than what? Is less than 1. As we need a condition where f of x is what? Bigger than 1. So it is happening for the condition of x values which are greater than 0. As we consider to the right side, these values of x, they are what? They are greater than 0. So this is how you compare. You just have to make your comparison with what you are given from the graph to say from which point to which point. So in this case, it is greater than this one, greater than 1 for the x value at what? At 0. All right. Let's say it was for y is equal to, let's consider this one because we also have another y value. Like I said here, we also have this one for y is equal to what? Y is equal to 8. At this point, to 8. If you were going to consider that one, they say you are given that your f of x is supposed to be greater than, they can say greater than 8. So you consider y is equal to 8. Y is greater than what? 8. And y is equal to 8 at this point, all right? Here, that's 2, 8. Y there is what? Is 8. So y is equal to 8 was going to be something like this. This is the line of y is equal to 8. So your comparison is made from there to say, for y is equal to 8, what is the x value at the intersection with the graph? The x value is what? Is 2. So this is your critical value. Like I said, the x value where y is equal to 8 on the graph, our x value is what? Is 2. So meaning to say, as 2 is our critical value, we are going to compare to the left side and to the right side to say, on this side, what is happening with our graph? It is below y is equal to 8. It is found below the line of y is equal to 8. So that it is less than. The y values, they are less than what? 8. But from this point to going to the right side, if you check, the graph is what? Found on top of the line y is equal to 8. The y values, they are greater than what? They are greater than 8. They are bigger than 8. They are going up, the y values, compared to this side, the y values where they are going down. So meaning to say, where f of x is greater than 8, we compare from the critical value where x is equal to what? 2. So that's, therefore, our x is supposed to be what? For us to have y is greater than 8, these are the x values from 2 going this side. So x is greater than what? X is greater than 2. So this is how you can answer these questions. It's a comparison. You just compare from that k that you are given. Even for the inverse, because you'll be having that graph, unless maybe mostly for the inverse, sometimes for a logarithmic, you can actually calculate the values without the graph, all right? But if you're doing graphically, this is what you're going to need, all right? Let us just check how these questions might be given. As we had this part here, determine the values of x for which f of x is what? Greater than or equal to -1. So f of x is greater than or equal to -1. It's a constant that you're given. So you must check where y is equal to minus 1. Where y is equal to minus 1. If you're going to check y is equal to minus 1 is at point C. This is x, this is y. Y is minus 1 there. So you're going to have, let us draw that line. So I'm just going to indicate the line of what? Y is equal to minus 1, which is going to pass through the point what? Point C, which is a horizontal line actually there. So this line that I have drawn, passing through the point C, like this, it is the line of what? Y is equal to minus 1. Remember, this is 2 minus 1. So it is the line of y is equal to minus 1. So they are saying the graph of f, all right? This is our f. This is our f. They are saying our graph of f must be what? Greater than minus 1, meaning to say our y values must be bigger than what? Minus 1. So the critical value there at minus 1 on the graph is what? Is 2. The x value is what? Is 2. So we compare from that 2 to say on the left side here, what is happening on the y values on what? On f. The y values, as we can see, compared to minus 1, they are above, they are on top of minus 1. They are on top, meaning to say these y values, they are greater than minus 1. From 2, we go this side, 2, 3, and so on. If we check the graph here, the y values, they are below the line of y is equal to minus 1, meaning to say our y values, they are less than minus 1. So which one satisfies where it is greater than? It is this one. Y is what? Where y is greater than minus 1 from this point, from 2. But remember, there is an asymptote. So on our graph, we are limited. X cannot be equal to what? X cannot be equal to 0. It's an asymptote. So our solution will be taken from 0 to what? From 0 to 2. We are saying that that is where our y values are bigger than what? Minus 1. The output, the y values. So it is the x which is greater than what? 0. Remember, 0 is an asymptote. So therefore, x is greater than 0, but less than or equal to what? 2. 2 is not an asymptote. It is a critical value, so it can be equal to 2. But not equal to 0, because that is a what? Is an asymptote. Our graph is limited. It cannot reach that. All right, so that is how you answer these questions. As you can see, these questions, guys, they are just direct. They are just direct, as we can see. All right, let's see this one. They gave us these two graphs, all right? On the two graphs that we are having, the question was here that for which value or values of x will the inverse of g be greater than or equal to minus 2? The inverse of what? The inverse of g. All right, so if you consider we do not have the inverse of g. We have got the graph of g here. This is the graph of g. All right, this is the graph of g. But here they are referring to its inverse. The inverse of g must be greater than or equal to minus 2. All right, meaning to say the y value on the inverse is compared with minus 2, the y value of the inverse. All right, no problem. We know that the inverse is as a result of reflecting this graph on the line y is equal to what? On the line y is equal to x, meaning to say this point, if we are to consider where x is equal to 0 and substitute here, it was going to give us a 1, y is equal to 1. So this is 1. It will be reflected to the other side where y is equal to 1. So this is this was going to be somewhere here where y is equal to 1. Then if we interchange this, swap those in the line of y is equal to x, remember you just swap. So it will be 4 minus 2. So there's a point on the graph which is referred to as 4 minus 2. Let's just say somewhere here. So this is it. Our inverse graph was going to be like this, something like this, something like this. All right. So it was going to pass through the point 4 minus 2. All right. That is it. And the y-axis is now our asymptote. Before, the x-axis was our asymptote. So this time, x is equal to 0 is an asymptote. All right. So this is our inverse. This is the inverse of g, guys. So they are saying that the inverse of g must be greater than or equal to minus 2, meaning to say we are comparing the y value to minus 2. Where do we have minus 2? Already we can see that at this point, y is minus 2. So this was the line y is equal to minus 2, which passes through the point what? The point 4 minus 2. That is the line of y is equal to what? Minus 2. For the inverse function that you're given, this is where we have got it's minus 2. If we are to consider where do we have values that are greater than minus 2, it is supposed to be on top. So what is the critical value now? The critical value is 4. Where y is equal to minus 2, x there is what? X there is 4. So x becomes your critical value now to say you are comparing your values from 4. This side, we are limited to the what? X is equal to 0. We are limited. Our values cannot reach 0. Remember that as simple thought. So where do we have values that are greater than minus 2? Here, our values are above the line of y is equal to minus 2. They are more than minus 2. So in our case here, y is greater than minus 2. This side, if you check from 4, the graph is below the line of y is equal to minus 2, meaning to say these values, they are less than what? Minus 2. As we need a condition which is greater than or equal to minus 2. So this is the region that we want. But it is limited from 0 to what? From 0 to 4. The critical value, the x value, where y is equal to minus 2 is what? Is 4. But here, it is now an asymptote. So therefore, x is greater than 0. Remember, x cannot be equal to what? Cannot be equal to 0. All right? Because it's an asymptote. But less than or equal to what? Less than or equal to 4. Remember here, this is the interval where the y values are greater than minus 2. So it is limited to what? To 4. Which is part of what? The critical values for there. 0 is an asymptote. So x cannot be equal to 0. That is how they ask these questions. As you can see, it's just a repetition, guys. Just a repetition. The inverse, where it is greater than minus 2. So have it and consider the line of y is equal to minus 2, above or below that line. So above the line, that is greater than, below that line, that is less than. Just like that. All right. Another question. It was given here. Px is 3 to the exponent of x. Write down the equation of the inverse. All right. So I'm not going to waste your time, guys, going into the inverse. It was the logarithmic. Remember, from exponential, you're going to have what? A logarithmic. Then from there, they wanted you to sketch these two, the inverse, the original and the inverse, then answer this question here. So for the sake of time, because we are used to these functions, we know that 3 to the exponent of x is just like this one that we just had now. The presentation is just like, right? It's just like a condition of this nature, just like this one, all right? So I'm not going to waste your time, guys. It was just going to be, I'm just going to put a sketch straightforward, 3 to the exponent of x. So this is what you're going to have. 3 to the exponent of x as an exponential. The x-axis is our asymptote. So it's just going to be an increasing function. So this is what we have where the y value, the y-intercept is 1, and the x-axis is our asymptote, all right? So this is our exponential function. That's our p in that case. then its inverse, which is the logarithmic, is the one as a result of a reflection in the line of what? Y is equal to X. So definitely this was going to be found there, which is 1. We're going to have 1 here. That was it. And the y-axis becomes our asymptote. So it was just going to be something like this. All right. So this is what you're going to have on the what? On the inverse. So here they want us to consider the inverse. The question here is on the inverse. All right. The sketch, guys, just do it. Determine the values of x for which the inverse is less than or equal to 3. So we consider now from the graph that we are having which condition when our when the inverse of what? Of p, which is our logarithmic, remember it's a logarithmic, log x base 3. Where is it that this inverse is what? Where is it that this inverse is greater than, or is it greater than? No, it is less than or equal to 3. Where is it found? Whether it is less than or equal to 3. Meaning to say we must have the y value at 3. But are we seeing that y value at 3? We are not seeing that one. So when y is equal to 3, what is the x value? Because we do not have that actually, where y is equal to 3. Because here this is 1 for x, 2, 3, and so on and so on. So it must correspond to the y value. The y value is supposed to be equal to what? To 3. Where y is equal to 3. This is 1, 2. So maybe let's just increase here so that it can make sense. So that it can make sense. It was just going to be something like this. All right, so this is our inverse. So let's say the line y is equal to 3 is here. Let's say this is the line y is equal to 3. All right, y is equal to 3. It means it was going to meet at a certain point with the inverse of what? Of p. At that point, what we need is the x value. The x value, so that we can tell to say from that x value, where is it that is below 3? All right. So what is the x value there when y is equal to 3? So it is either you're going to use the log to solve for that one, all right, or you can use any other method that is applicable. But for the log, it was going to be easier because you're saying y is equal to 3. So 3 is equal to log x base 3. So what is the value of x? 3 to the exponent of x, remember, from log form to exponent form. So it's 3 to the exponent of what? 3, which is 27. So when y is equal to 3, x at that moment is what? Is 27. So meaning to say that x, which is 27, guys, is our critical value, the one that we are going to use for our comparison now to say from that x, which is 27, what is happening with the inverse? Our inverse here on the right side, it is found above the line y is equal to 3. So meaning to say it is greater than 3. But if you check this side, guys, it is below. It is below that line of y is equal to 3, meaning to say it is less than what? Less than 3. So our question was, where do we have the inverse less than or equal to 3? So the less than part is this one. For the values of x limited to 27. From where? From the y-axis. Remember, it cannot reach the y-axis because that's an asymptote. It is limited. So meaning to say, therefore, our x was going to be greater than 0. But less than or equal to what? 27. We are limited to what? To 27. Yes, x can be equal to 27. It's not an asymptote. That is where the inverse of what? Of p is less than or equal to 3. It is found below the line y is equal to 3. From 27, as we go 28, 29, the graph is now found above. These are the conditions where it will be asking you for the inverse when it is greater than or equal to 3. It is now above. So there you can write x is greater than or equal to what? 27. We are limited from what? From 27. The graph is now above y is equal to what? Y is equal to 3. So this is how you answer these questions. All you just need are the critical values, which is compared the value of x where y is equal to the constant. So where y is equal to 3, what is the value of x on the graph? That is your critical value. Then you compare from there. Is the graph below that line or is it above that line? When it is below, it is less than y is less than that. Above, y is greater than that. Just like that. So let's revise, guys, as many questions as we can, as we are preparing ourselves for the exams that are ahead of time.